Okay, so we're going to talk about how the energy systems interact. Okay, so we've talked about three primary systems. We've talked about ATP PCR, we've talked about glycolysis or anaerobic metabolism, and then we've talked about aerobic metabolism. Okay, now we're also going to talk about fats and carbs here a little bit. So I want you to take a minute and look at this figure here. So let me orient you. So on the x-axis, we've got time. On the y-axis, we've got percent of total energy. Okay, and then we've got three different systems. We've got phosphagen, glycolytic, oxidative. Okay, so what do you see here? And we've already addressed a couple of these things earlier. So it's important to know the energy systems are not activated at the same time. Okay, and they're not even activated 1, 2, 3. Okay, if you look here at the bottom, as soon as we start exercise, there we go. As soon as we start exercise, we're activating all of these systems. Okay. But some systems are dominant, or each of the systems is dominant at a different time. Okay, and so it depends on the duration, really, of what's going on. Okay, so if we do something that's like a sprint, right? Remember we said the ATP PCR system's really active for the first 10, 15 seconds, and then it just falls off a cliff because we don't have the substrates required, right? So at the very beginning, lots of ATP PCR. There's some glycolysis and even a smaller amount of oxidative ATP that's coming from the oxidative system, but it's not much. Okay, but then as we go into that, 15 to, even 90 seconds there, it's mostly glycolysis. But as we get to the end of glycolysis, that oxidative system really starts to come into play. And once we get over 2 minutes, essentially, it's primarily an oxidative thing. Okay, now this is in part related to what we call the crossover effect. And when it comes to fuels, we use two different fuels. We use fats and we use carbs. Now, as I said on a previous video, with fats, it takes a little bit longer, requires a little more oxygen, so we rely on fats during low-intensity exercise, okay, up to about 60% of our maximum aerobic intensity. After that, we really start using carbohydrates, but it's similar to the fuel systems, with the exception of like at very, very low intensities where we're almost only using fats. We start exercising at all, we start using a little more carbs, a little less fats. So why do we use carbs during high intensity exercise? I mean, this is a valid question because we've got lots and lots of fat. You're never going to go through 70,000 calories. Okay? And you think about it, one free fatty acid produces 3 times more ATP than a glucose molecule. So one triglyceride produces almost 10 times as much as a glucose molecule. Again, the answer is fat oxidation occurs more slowly and it requires more oxygen. So during high intensity exercise, we need ATP, we need a lot of ATP, and we need it now. And because it occurs more quickly, metabolism of carbs occurs more quickly, we start to rely on that. But what's really interesting is the training can affect what we call that crossover. And just to go back here, crossover is this point right here. If I can find my cursor again, there we go, we're up at the top. So this is the crossover right here, where we start burning more carbs than fats. Well, with training, it allows us, we become better at using fats. This allows us to hold on to carbs. We use them later. And then as a result, we can go for a longer time. We have greater endurance. And that is how we use the different energy systems.